All right. Eating chips. Jeez. All right, 63. Y equals 1 plus cosecant x over 1 minus cosecant x. How do we do this? I mean, I know we're finding the derivative. How? Quotient rule. So we do the derivative of the top. What's the derivative of cosecant? And then times the bottom. Minus. Is everybody okay with that? The derivative of the bottom, 1 minus cosecant x. Minus minus makes a positive. Times the top. All over the bottom square. You're going to distribute. Here, negative cosecant x cotan x times 1 is just the same thing. Negative cosecant x cotan x times cosecant x is cosecant squared x. It changes to positive because they're both negative. Cotan. I'm going to distribute my negative and my cosecant at the same time. So negative cosecant cotan x and minus cosecant squared x cotan x all over 1 minus cosecant x squared. And then what happens? And then these two. They're both the same, right? -1 plus -1 is. So this one will be -2 cosecant x cotan x over 1 minus cosecant x all squared. That's it. It just looks massive. It's not that bad. All right, 67. You had f of x equals x cubed plus 4x minus 1 times x minus 2, and it gave you the coordinate 1, -4, and it wanted you to find the line of the tangent. Okay. So the first thing that I would do on this, I don't want to use the product rule. I can go ahead and multiply it out. So I'm just going to go ahead and distribute. You get x to the third plus 4x squared minus x. So I distributed, sorry, it should be x to the fourth. I distributed my x. Now I'm going to distribute my -2. So -2x cubed minus 8x plus 2. And then I'm going to put it in order and add my like terms. So x to the fourth. I have a -2x cubed, a 4x squared, a minus 9x, and a +2. Now it's easier to take my derivative instead of having to use the product rule. So what is my derivative of all this? Very good. What do we do to find our slope? So our x was 1. which gave us -3. You can leave it in point slope form unless it asks you for something different. I would just leave it in point slope, especially when you get later on and you're using like pies and stuff like that. Just leave it. Don't try to fix it. Okay. So we have y plus 4 because our y coordinate up here was -4. We changed the sign. Our slope was -3, x minus 1. When you work that all out, if you want to solve for y, it does turn into -3x minus 1. Right. 71. There may be a couple that I skip on here just to throw that out there. F of x equals 10x. This is a quick one. Pi over 4 and 1. This is one of those that I would just leave in point slope form. Sorry. What's your derivative of tan? Secant squared x. You're going to plug in your x. What is secant? In your calculator, you can do it like this. Okay. That gives you 2. It's not tan, it's 1 over cosine. 1 over cosine. Gives you 2. So then your equation y minus 1 equals 2 times x minus pi over 4. And like I said, I would just leave it like that and try not to. You guys okay with 77? Is an easy one. Everybody okay? 77. Do we need help with 81? Also an easy one. Everybody good? 81. Try to skip. Okay, if you can't, you need to let me know, okay? 83. Again, same thing, everything really reduces out. Everybody good with 83? All right, 91. I know some of you will have trouble with that. All right, 91 was C equals 100 times 200 over x squared plus x over x plus 30, x greater than or equal to 1. I went ahead and distributed my 100. Everybody okay with that? Since this didn't have a plus or a minus, I also just went ahead and moved that x squared up. Again, anytime that I don't have to use quotient rule or product rule, I want to try not to do that. All right, so now we found the derivative. What's your derivative of 20,000 x to the -2? Everybody good with that? And then on this side, I'm going to have to do the quotient rule. Sorry, -3. Thank you. Quotient rule on the other side, derivative of the first. Derivative of 100x. 100 times the bottom minus derivative of the bottom. I'm not doing this for you just to watch me. derivative at the bottom, x plus 30. 1. Multiply by the top. All over x plus 30 squared. Clean it up. You can go ahead and rewrite this 40,000 over x to the positive 3. Inside, we're going to distribute our 100, so we get 100x plus 3,000 minus 100x over x plus 30 squared. What happened? So just rewrite what we have. You can leave it just like this. I took out, you can take out 1,000 if you want to. You don't have to. You can leave it just like this. But then it said to plug in 10, 15, and 20. So when you plug in 10 up here, you get negative 38.13. When you plug in 15, negative 10.37, and negative 3.8. On ones that I work out that you were just copying down, if you have something like this, this is fine. If for some ungodly reason you turn in a paper, you should not, that has the problem and then the derivative right next to it with no work, and then what x, the 3 x's are, you cheated. I'm no dummy. How many of you did all this homework without any work showing? How many did any problems without any work showing? People not showing the work. Period. Homework assignments. So 3.2, there was a lot of questions that you didn't have to show your work, right? Have there been on 3.3? Was there on 3.1? Remember 3.1 was that limit definition, right? So we got to show work, guys. If we're not, I'm not counting it. That's only going to hurt you on the test. You're not going to know how to do it. All right, there's 91. Not much work to 99. I can tell the difference between them. You should be fine with 99, but I'm going to go ahead and grab it real quick since it's a double prime. F of x, f of x is 4x to the 3/4. F prime is the derivative of that. So 3/4 times 4 is what? I'm sorry, it's 3/2. I can't read my writing. 3/2, sorry. Yeah, 4 times 3 is 12, divided by 2 is 6. X, and y'all, I do like this, minus the 1. 1 would be whatever your denominator is over itself, which will give you 1/2 or 6 square root of x. Your double prime, what's half of 6? X to, again, the 1 less power would be negative 1/2 or 3 over the square root of x. It should have been your second derivative. Do we need to do 103? Everybody's okay with that one? It's pretty easy. 109 was pretty easy as well. What about 111? Yep. Right. So 111 said f of x equals 2 g of x plus h of x. So they gave you what g prime and h prime were, right? Everybody remember that? Okay. So we're going to go ahead and find the derivative. So that would be 2 derivative of g of x plus the derivative of h of x. And it wanted you to find f of 2 based on that. So the way you do that is you use h prime of 2 and g prime of 2. Right? You get 2 times -2 plus 4. Again, the -2 and the 4 were given to you. That's not something that I just pulled out of my hat. And then it gives you 0. $113 was the same exact way. It's just going to be with your quotient rule. So we are going to go over 113. But it literally is the same way. So you're going to find the derivative on 113 of f of x, which is g of x over h of x, using the quotient rule. The derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom square. They gave you all of these to find f prime of 2. They gave you g prime of 2 was -2. Here, you've got the office. You're not leaving or anything, but you're coming back. Listen, I'm just saying. And h prime of x, h of x they give you, so h of 2 they gave you was -1, unless that I switched those when I wrote them down. And then 4 and 3. And again, h of x was -1 squared. This gives you 2 minus 12 over 1, or -10. All right. Do we need to go over 133? Did they give you that other equation, the x cubed y double prime? Okay, good. Eventually, you're going to do that yourself. That's what we'll do in like 35. All right, x is greater than 0. So we're going to change this y to x to the -1. So what would your y prime be? -1, x to the -2, right? So what would your y double prime be? Not -2, but +2, x to the, which is y. Bring down your power, 1 less power. So when I bring down my power, it's -1, -1, okay? The y double prime, the next one, -2 times -1 is +2. So the 1 less power is -3. Yeah, just doing it again. So then they gave you x to the third y double prime plus 2x squared y prime equals 0. And you're just going to plug them in. This one was -1 over x squared. All right. So we got x cubed. Y double prime was 2 over x cubed plus 2x squared. Y prime was -1 over x squared equals 0. What happens? If it's the same on the top and the bottom. Cancel your x to the third. Cancel your x squared, you get 2 plus 2 times -1 which equals 0. Any questions? Everybody okay? All right. 3, 4. All right. 3, 4 is the chain rule, and it's really not bad. This section is just wrong. Okay, so I may split your homework up a little bit, but again, it's gonna take us 2 days to go through this, just because, I mean, it's a packet of notes. So here we go. The text has yet to discuss one of the most powerful differentiation rules, which is the chain rule. This rule deals with composite functions. That means a function within a function. That's not like where you were doing f of g. It is a composite function, but doesn't look like a composite function. It would be like cosine of 3x plus 1. That is a composite function because there's a function within the cosine function, if that makes sense. It's not a complicated rule, okay? And adds a surprising versatility to the rules discussed in the 2 previous sections. For example, compare the functions shown below. Those on the left can be differentiated without the chain rule. And those on the right are best differentiated with the chain rule. Okay, so here's what I'm talking about. These two are just regular, like sine x is really a composite function, but what's the derivative of x? 1. So it does absolutely nothing. But when you put a 6 in there, it changes it. So this is the function within the function, okay? Where you have not just square root of x, you have square root of x squared plus 1. So there's a function inside that square root. Instead of just sine x, it's now sine 6x. Instead of x to the 5th, it's now 3x plus 2 to the 5th. So you understand where that composite part is coming from. There's a function within a function. Basically, the chain rule states that if y changes, dy over du times as fast as u, and u changes du over dx times as fast as x, then y changes dy over du times du over dx times as fast as x. Makes no sense, but it's a really easy rule, okay? I promise. So all of these like dy's, dx's, du's, whatever, they're a little bit crazy. This first example is probably going to throw you off a little bit, but once we get into the actual derivatives, you're going to be perfectly fine. It's take the derivative of the outside function times the derivative of the inside. It's real simple. All right, so we're going to look at this first one. A set of gears is constructed so that the second and third gears are on the same axle. As the first axle revolves, it drives the second axle, which in turn drives the third axle. Let y, u, and x represent the numbers of revolutions per minute of the first, second, and third axles respectively. So third is u. I lied to you. third is not u. The first is y. Let me go there. The first is y. That's this axle right here. The second is u. That's why I labeled 3, I'll tell you. And x is axle 3. So this 3 right here is going to deal with that u because the second axle or u turns it. This 1 is going to deal with y because the y axle turns it. And this 2 is going to deal with x because the x axle turns it. Find dy over du, du over dx, and dy over dx, and show that dy over dx equals dy over du times du over dx. Sounds crazy, but it's not, okay? So we're going to start with dy over du. Dy over du is how fast it turns based on the other one. So that's going to be your 3. Your 3. Your dy over dx is going to be the 2. So what goes with u is 3. What goes with dx is 2. Dy over dx represents the rate of change. And it told you this in the problem of the first axle. With respect to the second. Times the rate of change. Of the second with respect to the third. Yes. Yes. All right. So what I just wrote here was this formula. Okay, but I wrote it in words. So dy over dx equals dy over du, which is 3, times dy over dx, which is 2, and it's going to give us 6. This would be the rate of the first with respect to the third. All right. In other words, the rate of change of y with respect to x is the product of the rate of change of y with respect to u and the rate of change of u with respect to x. All right, so all this is doing is trying to prove the chain rule. And this is a simple form of it, and that's what it's going to say at the bottom. The last example illustrates a simple case of the chain rule. And again, right now, it's probably not making any sense, but in a second it will. It's super easy. Remember, the derivative stuff is the easy stuff. It's making it look like the answer in the back of the book. That's the hard part, okay? So I promise you, I'm telling you the truth when I say that. Okay. So here is the chain rule. If y equals f of u, it's a differential function of u, and u equals g of x is a differential function of x, then y equals f of g of x is a differentiable function of x, and we'll stop right there for a minute. So let me talk about this for a minute. If y equals f of u is g of x, so we can plug g of x in for u. That's where they get this. There's your composite that they're talking about. Okay, g of x is within f of x. dy over dx, y'all, that's just another word for the derivative with respect to x, is dy over du times du over dx or equivalently d over dx of f of g of x is f prime of g of x times g prime of x. Still probably makes no sense until we do a problem, and then you'll understand it. All right, so let me give you an example. If you had sine 2x plus 1, okay? So let's say sine of 2x plus 1, because we know these derivatives. You're going to take the derivative of sine. What's the derivative of sine? With that same function inside. Then you're going to multiply it by the derivative of the inside. What's the derivative of 2x plus 1? 2. Is everybody good with that? So your final answer is 2 cosine 2x plus 1. That's chain rule. Okay, take the derivative of the outside and then take the derivative of the function. It's that simple. When applying the chain rule, it's helpful to think of the composite function f of g as having two parts, an inner part and an outer part. So y equals f of g of x is the same thing like we said of f of u. F is that outer part. U is the inner part. The derivative of y equals f of u is the derivative of the outer function. That's what I just showed you with sine, the derivative of sine at the inner function u of 2x plus 1 times the derivative of the inner function. And then we times it by the derivative of 2x plus 1. So it is the same thing. I think it looks easier like this, and all of your sine, cosines, tangents, all your trig functions are set up like this. So f prime of u times u prime. So on these, we're not finding the derivative. We're just going to decompose and talk about the two different functions that we have. So remember, we have an inner and we have an outer. So the inner one is a little bit easier to figure out. But I think they're all easy to figure out. What is the function inside the function? So what part of this makes it hard? X plus 1. And your f of x would be 1 over what would make it easy if that was just x. So we replaced x with x plus 1 right here. So think of the most basic function that you could have. That's your f of u. What makes it hard is your g of x or your u. So on this one, we have sine of 2x. What part makes it more difficult? The 2x. What's your original function? Just sine x. What part makes this one hard? And then what's your original function? And then be careful of this one. I'm gonna rewrite it for you like this. So tan x squared. What's your inner function? On this one, it is tan x, and your outer function would have been x squared. That's it. Huh? It's not. It's really not. Like I said, what's the hard part of doing derivatives? Simplifying them. Simplifying them is harder than actually finding the derivative. All right. Find dy dx, find the derivative, for y equals x squared plus 1 to the third. So this is how they like to write it. We want to find the derivative of u to the third and then multiply it by that u prime. So treat this like it's x to the third. How would you find the derivative of x to the third? Okay, so the 3 is going to come down. We would put the x back, but on this one, we're going to put the inside back. And then what would your new power be? Everybody good? So same thing. That set of parentheses, bring down your 3 to the 1 less power, but then you're going to multiply it by the derivative of the inside. What's the derivative of x squared plus 1? So clean it up. What's 3 times 2x? Times x squared plus 1 squared. That's it. Any questions? All right, the general power rule. The function in the last example is an example of one of the most common types of composite functions, which is y equals, that's a bracket, u of x to the n, u of x to the n. It's a normal power rule. The rule for differentiating such function is called the general power rule. And is a special case of the chain rule. And if you can't see that, I'll move it in just a second. I wanted you to be able to see that power. So if y equals u of x to the n, where u is a differential function of x and n is a rational number, we just did it. We're going to bring the n down, keep the function to the 1 less power, times, that's a u, not a y, the derivative of the function inside. Or if you'd rather look at it like this, d over dx equals n u to the n minus 1 times u prime. That's how I like to look at it. That other stuff confuses me. dy over dx like really messes with my brain a lot. So be ready to do that though, because you're going to start taking the derivative of y, and every time you do that, you have to take dy over dx. It's not hard. It's just remembering to write it. Okay. All right. Applying the general power rule. Find the derivative of f of x equals 3x minus 2x squared to the third. So treat it just like a regular derivative. So what's going to happen first? Power down. Rewrite the function 3x minus 2x squared to the 1 less power. Normal derivative. The new part was they're going to multiply it by the derivative of the inside. So what's the derivative of 3x minus 2x squared? Minus 4x. Leave it just like this. Don't do anything else. The only thing you could do is distribute your 3, but you're not going to multiply them all together or anything like that. So it's good just like this. All right, find all the points on the graph of the f of x equals the cube root of x squared minus 1 squared, for which f prime of x equals 0, and those for which f prime of x does not exist. All right. So here's what you have. Remember, we can write this cube root as a power, but we have a 2 underneath. So remember, I told you when you change it from radical to fractional power, this is the power underneath times the root, or over the root, sorry. So what's our power underneath? So this is actually u to the 2/3, and then we're going to multiply it by u prime. Everybody see that? So we're going to change it to the 2/3. And then all of this, all of that x squared minus 1 is what u is. That's what u is. So how do I differentiate this part right here? Treat it like x to the 2/3. Bring the 2/3 down. Times u to the, what's 2/3 minus 1? Negative 1/3. And again, we're going to hold off for just a minute, times u prime. So we have 2/3. What was u? X squared minus 1 to the negative 1/3. So then what would be that u prime? X squared minus 1's derivative. Perfect. Perfect. All right. Clean it up. What can I do? Absolutely. And do what to it? Make it a cube root. So we'll start there. I know that that cube root goes on the bottom. What else is going to go on the bottom? The 3 is already a denominator, right? What's going to go on top? This 2 and 2x, which is 4x. So this is your derivative. It says find for which f prime of x equals 0 and those for which it doesn't exist. So we want to set f prime equal to 0. Remember, we multiply by the whole bottom, which is going to do absolutely nothing, right? Does everybody understand that? The bottom doesn't matter in this situation. So we get, 4x equals 0. And what do we get for x? Okay, so there's one answer. That's where f prime of x equals 0. Where would it not exist? Louder. Yeah, where we have a vertical asymptote or a hole or anything like that, a point of discontinuity. So we don't have a hole because we don't have anything to mark out, but we could set our bottom equal to 0. So 3 cube root x squared minus 1. You shouldn't have to do all this work, but I'm going to do it anyway. How would you solve? Come on, go. Divide by 3. It does absolutely nothing, right? Gives me the cube root of x squared minus 1. How do I get rid of the cube root? Cube still gives me 0. And then? So what's the square root of 1? Positive, negative 1. There are your points of discontinuity. All right. Any question on those? Okay, so that added some extra in. I really just want to focus on taking the differentiation or doing the derivative. So look at your next one. We're going to find the derivative of -7 over 2t minus 3 squared. Be smart about this one. What am I going to do? Why? Yeah, I don't want to do quotient rule, right? So let's move it to the top before I even start. And then again, treat it just like it's -7x to the -2. How would I find that derivative? -2 times -7. Sorry, +14. 2t minus 3 stays, and the one last power is -3. The new step is multiply it by the derivative of the inside. What's the derivative of 2t minus 3? 2. So what is my final derivative? Fourteen times 2 is 28. This cube root on the bottom. Not cube root, cube. Sorry, happy Monday. Any questions? So again, we're only doing one extra step, taking the derivative of the inside. The next 3 examples demonstrate techniques for simplifying the raw derivative of functions involving products, quotients, and composites. Products, quotients, and composites. So all this is the chain rule within the product rule. Did I got it? Chain rule within the product rule. How can I clean this up before I even start? Perfect. So again, there's your product rule. What makes it have the chain rule is this 1 minus x squared. That's it. So how do we do the product rule? Derivative of the first is? You said times the second. Plus. How do I find the derivative of the second? What's the derivative of that? 1/2. Don't forget to times the derivative of the inside. So what's the derivative of 1 minus x squared? -2x. And then the last step, don't forget, times the first. When I do the product rule, that's always the one I forget. I get the derivative of the big chain rule, and then I forget to put the first function. Okay. All right, clean it up. How do I clean it up? No. Say it again. I just can't hear you. I'm sorry. Okay. What else? Can I do anything else? Change this to minus x to the third. What do I need to do now? Common denominator before I do that. Common denominator, because they're fractions, one of them is a fraction, I need to be able to subtract them, so I need this multiplied by the square root of 1 minus x squared, so that I can put it on the bottom here. So that would give them a common denominator of 1 minus x squared. The 2x, what happens when you multiply these two square roots? 1 minus x squared minus x cubed. Now what can I do? You're almost there. What can I do? Distribute. So 2x minus 2x cubed minus x cubed over 1 minus x squared. What can I do now? What do they have in common? I'm gonna do it all at one time if y'all don't mind. When I combine these, negative 2x cubed minus x cubed is negative 3x cubed, but I'm gonna take that x out. Do you have to? I don't think so. I think you'll be fine. But if you want it to look like the book answer, this is what it is. Great job. And you did that without knowing what the answer was. So you can do it. Just make it as simple as possible. All right. Look at your next one. I'm going to leave this one. I'm not going to make it to the negative 1/3. You can if you want to, but I'm not going to. I'm going to do this one quotient rule. Can you do it that way? Absolutely. Absolutely. But I'm going to do this one quotient rule because it says derive the quotient. Okay. So quotient rule says do what? All right. I'm going to fix the bottom though real fast. All right. Derivative of the first one is going to be 1 times the bottom minus the derivative of the bottom is what? Times to the negative 2/3 times. Remember the extra step is the derivative of the inside. Don't forget the top. All over the bottom squared. I'll clean it up. Cube root of x squared plus 4 minus, what's this turn into? Think about everything that's already going to be on top. What's going to be on top? So 1 times 2x times x is 2x squared. You're right, you're right. And then x squared plus 4 to the negative 2/3. I'm gonna hold off on doing anything with it just yet. All right. See, wait a minute, I lost my 3. I lost my 3 right here. All right, so from here, because I have some crazy stuff going on, you guys can fix it. We'll just keep fixing it like we normally do. Cube root x squared plus 4 minus 2x squared over 3 times the cube root. I'm gonna leave it as fractions. I think you'll see it better that way. X squared plus 4 to the 2/3. All over the cube root x squared plus 4 squared. All right, so what's on common denominator? Mhm. So this needs a 3. And it needs an x squared plus 4 to the 2/3. What was this one? How do I fix this one? This one is the what? What fractional power? 1/3, right? What's 1/3 plus 2/3? Is anybody confused on what I just did? 2/3 plus 1/3 is 3/3 or the 1 power. But we had a 3 outside, so we have that now. Clean it up some more. I'm gonna move up here so you guys can see a little bit more. We'll have 3x squared plus 12 minus 2x squared over 3 times x squared plus 4 to the 2/3 all over the cube root of x squared plus 4 squared. What are we gonna have on the top? Clean up the very top. What are we gonna have? Remember, I flip and multiply, so I'm gonna go ahead and do that from here. 1 over the cube root of x squared plus 4 squared. On the top, you still have the x squared plus 12. On the bottom, you definitely have that 3. What is this going to fix to? The cube root of x squared plus 4 squared. What power is it going to be if I don't write it as a square root or a cube root? 2 over 3. We have 2 over 3, and 2 over 3 makes 4 over 3. This is your final. There's nothing else that you can do to that. That is what makes this section so long. Does everybody understand that? You don't have a ton of those problems in your homework, but you, just like always, you'll have a couple of them. Okay. So again, just keep trudging through it. I think we'll do this next page. Let's try to get 2 more pages in and then we'll be done. And then I won't even give you homework. Okay. They're not hard. This one is the longest one out of all of them. All right. So on this one, I'm going to do the regular rule. So I have that 2 on the outside. So I'm going to bring that 2 down to the 1 less power and then do the quotient rule on the inside. So again, bring down your power. To the 1 less power would be 1. All right. All right. Mr. Davis, Sandra Cruz. All right. Quotient rule, derivative of the top. Derivative of the top. Times the bottom. Minus the derivative of the bottom. Times the top. All over the bottom squared. These are not as bad because they're easy little functions. They're not the 1/2 or the 3/2 or anything crazy like that. I'm going to go ahead and distribute my 2. Maybe I am. You're going to get 6x minus 2 on the top, x squared plus 3 on the bottom. Distribute your 3 in the top. You get 3x squared plus 9. Distribute your 2 and your negative, or a negative 2x. Negative 2x times 3 is negative 6x squared. Negative 2x times negative 1 is a positive 2x. And then you don't have to multiply out the top, just clean it up and combine the bottoms. So 6x minus 2 can stay right there. You don't have to do anything with that. You could have even left the 2 out. It doesn't matter. 3x squared minus 6x squared is, we have a positive 2x and a positive 9. All over x squared plus 3. There's 3 of them to the 3rd. So again, that one's not bad because it don't have, anytime you have fractional exponents, it's going to take a long time to fix. Okay. Here are your trig functions. You, at this point, should know your derivatives. That's nothing new. They're the same derivatives. The only difference is now they have a u prime next to them. So whatever that function is inside, times it by the derivative of that function. So it's the same exact thing. So here, what's the derivative of sine? Cosine. So we're going to write cosine 2x and then multiply by the derivative of 2x, which is 2. So this one is 2 cosine 2x. What is the derivative of cosine? Negative sine. Make sure you use the function that's in there. And then multiply it by the derivative of the inside. What's the derivative of x minus 1? So this is negative sine x minus 1. The derivative of e to the x is e to the x. So we keep it the same, e to the 3x. Times, what's the derivative of 3x? So this one is 3e to the 3x. Notice it's still that quick. Unless you have to do product quotient rule, it's still that quick. It's still the same thing. All right. Your next ones. They just rewrote this one for you. Cosine 3x squared is the same thing as cosine of 3x squared. What's your derivative of cosine? negative sign, use the function on the inside, 3x squared. And then what is the derivative of 3x squared? So this one is negative 6x sine 3x squared. And again, whether you use parentheses or not is up to you. It's all the same. Look at the difference in this one. I would almost even rewrite it as x squared cosine 3. So you're not looking at it like x squared is part of that cosine. So what would I have to use on this? Product rule. So what's the derivative of the first? Times cosine 3 plus, what's your derivative of cosine 3? Yeah. But what's your derivative of 3? 0, right? Everybody see that? Watch that right there. So if they give you cosine 3, you're going to do the negative sine 3, but then it's going to give you 0. Remember, cosine 3 is going to be a number. It's going to be a constant, so the derivative is going to be 0 anyway. All right. And then times your first function, which was x squared. All of this cancels out. Why? Multiplied by 0. So we should just have 2x cosine 3. All right. So they changed this one up a little bit. If you get cosine 3x squared, go ahead and multiply it out. What's your derivative of cosine? Again, of 9x squared. But then we have to multiply by the derivative of 9x squared, which is 18x. So your final is negative 18x sine 9x squared. Anything bad? Not too bad, right? It's pretty quick. So again, the ones that are tough are the square roots or cube roots. These will be tough. Look at D. Remember, cosine squared x is the same thing as cosine x all squared. So for this one, we're going to use the regular power rule. Bring down the power times the function to the 1 less power. I put the 1 up there just so you could see it. Times, what's the derivative of cosine x? So we get negative 2 sine x cosine x. If you gave me negative 2 cosine x sine x, it's the same. Oh, it's the same. Multiplication doesn't matter the order. And then the last one. And then we'll do that last example and we'll be done. I'll give you a break. Square root of cosine x is cosine x to the 1/2. Bring down the power. Keep the function to the 1 less power. Times the derivative of the function. What's the derivative of cosine x? So clean it up. The 2 and the cosine x are going to go on the bottom. The negative sine x stays on the top. And it looks like this. And then, like I said, one more example and we'll stop. How do I rewrite this? Change it. Change it before you start. Sine 4t all to the 3rd. Find your derivative. Tell me how to do that. Bring down the power. So 3 times what? Sine 4t squared times. Be careful about this one. Cosine what? What's the derivative of just sine 4t? Cosine 4t. But what else do you have to do? You did it a minute ago. You did sine 6x, and you said it was cosine 6x times 6, right? So what's this one? Times 4. So you had to do chain rule within the chain rule. Okay, so be ready for that. So then finish it out. What's 3 times 4?
Well,
Get on that, Sammy.
I need something for this.
Sine squared 4t, cosine 4t. Again, if you have it flip-flopped or anything like that, you're good to go. All right. We'll finish this up tomorrow. It just talks about logs. So they're not too bad. I'm not going to assign any homework. There are not any super long problems tomorrow, so we should be finished quick.